In this video, we will be going over a more advanced example of configuring the PI UFL interface. If this is your first time working with the UFL interface, I recommend that you first watch the From Install to Data video, as it goes over a more simple example. Before we start creating variables, let's take a look at the data in our file. The data that I'm using the UFL interface to read and send to PI is a lab analysis of silicon material from a reactor. The first line in the file, denoted by an S, contains information about the timestamp of this lab data and the reactor that the silicon material came from. The second line, denoted by a D, specifies the instrument that was used for the analysis. This information isn't relevant for me to send to PI, so I can just ignore this data line. The rest of the lines in the file contain the results of the analysis and the element that each result is corresponding to. Let's start our advanced configuration by opening PI ICU. I've already created a new instance of the PI UFL interface ahead of time. Select your UFL interface from the drop-down menu. Then go to the UFL tab. We'll now specify a configuration or INI file. Select the ellipses to the right of the configuration file box. Navigate to the PI UFL directory. This should be located in your PyPC Interfaces folder. In the PI UFL directory, go to the INI folder. This is where we'll save our INI file. I'm going to call my INI file example2. Now that we've defined an INI file, we can launch our UFL Designer and start configuring our INI file. Click Yes to continue. Here, we're prompted to select a plugin for our INI file. The UFL interface can read data from a few different sources, including ASCII files, serial ports, and POP3 mail servers. There's a plugin to go with each of these data sources. Since we'll be reading in data from an ASCII file, we'll select the ASCII Files plugin. You can select other plugins from the drop-down menu. We also need to select a data file to use as reference while configuring our INI file. Click the ellipses and navigate to your data file. Then select Open. We're now ready to start configuring, so click OK. UFL Designer is split into 3 panes. The first pane on the left is where UFL Designer will guide us through the steps of configuring our INI file. The center pane shows the data file that we've selected as reference. The pane on the right shows our INI file as we configure it. On the left pane, our first step is to specify parameters for our plugin and settings for the interface. I'll go over a few of these parameters in detail. You can look up the rest, and the ones I go over, in the UFL user manual. The user manual contains a list of these parameters and detailed descriptions of what they do and how to use them. The first and most important parameter is the input file mask. This tells the interface where to find new data files and which of these files are data files that our interface should read. You can specify a local directory or a network location. I want my interface to read in all data files in the C data files directory with the extension .txt. I can tell my interface this by using a wildcard character. I'm going to use the wildcard character star to tell my interface that I want it to read any file with the .txt extension in the C data files directory. We can also tell the interface what order to read files with the input file sort parameter. You can tell the interface to order files by file name, creation date, or modification date. The prepend file name parameter, when enabled, tells our interface to read in the file name of our data file as the first line of data. This can be useful if your file name contains information like timestamp or tagname. You can also specify a fixed line size for your data file or special line end characters that are different than the standard ASCII line end characters. In the settings section, you can specify information about the log files, as well as what to do with any errors that the interface experiences. You can also specify a locale for the interface to use so that it knows the format of numbers. Now that we've finished the first step, let's click the blue arrow in UFL Designer to move on to our next step in configuring the ini file. In this section, we'll create variables for every piece of information that we need from our data file. You'll notice that there are no tag names specified in my data file. So how can I send my data to PI if I don't have a tag name? Well, we can assemble tag names from other information in this file. I'll want my tag names to be in the format reactor X, representing the reactor that the material came from, underscore, and then the name of the element that the result is for. So the variables that I'll need are the timestamp from the first line, the reactor from the first line, and then the elements and values from the C lines, highlighted in green. So let's create those variables. I can create a variable by clicking the green plus sign. I'm going to give my first variable for timestamp the name timestamp. I'll also need to select a data type for my variable. My timestamp data type will be datetime. Once I've selected the datetime data type, a new parameter appears called dateFormat. This is where I tell the interface what format my timestamp will be in. If I look at my timestamp, we'll see that it's in the format month.day.year, followed directly by the hours, minutes, and seconds. There are a bunch of pre-configured formats for date format, but I'm going to specify this one by hand. I've now told my interface the format of the timestamp. You can find further information about how to configure date formats in the UFL user manual. Now let's create a variable for our reactor. Since this variable is going to represent the prefix to my tag name, I'm going to call it tag prefix. And the data type for my tag prefix is string. Let's now create another variable for our element name. We'll call this variable element. And again, it's of data type string. The last variable we need to create is for our value. I'll call this variable value and give it a data type of number. We've now created all the variables that we need. So we can move on to the next step by clicking the blue arrow. In this section, we'll tell the interface which lines of data it should read. We'll need a separate message type for each different line format in our data file. If you recall from our discussion before, there's useful information for us in the first line, denoted by S, and then in the data result lines, denoted by C. We'll need a message type for each of these line formats. Let's create a message for our first line by clicking the green plus sign. I'm going to call this message header because it's the header of the file. We also need to define a filter for this message. The message filter tells the interface how to recognize a line of this type. We'll need some unique identifier in the line so that the interface will be able to recognize it. Our data file has defined this line with an S at the beginning. Let's tell our interface that any line that starts with S is a line of type header. In the message filter, we'll specify C1, which means the first character in the line, is equal to, then we can type S. Now our interface will know that any message that starts with the letter S is a header message. There are a few other parameters that we can configure: enable point creation and inherit tag attributes. I'll discuss these in the next message. Now we need to create a message for all our lines that contain the lab analysis results. Let's click the plus sign to create another message. We'll call this message data. Similarly to our header message, we can create a message filter that tells the interface that any line that starts with C is going to be a data line. Now let's talk about the enable point creation parameter. If this parameter is enabled, the UFL interface will automatically create a new point if the point specified does not exist yet. Let's enable point creation since I don't have any of these tags created on my Pi server yet. You can specify the type of point that we want to create. Since all of our data is in a decimal format, I'm going to specify that the interface creates float 32 points for all this data. The inherit tag attributes parameter can be used to specify an existing tag that the interface should use as a model for the tags that it creates. Otherwise, it'll just use default values. Now that we've specified both of our messages, we can click the blue arrow to move on to our next step. In this section, we'll tell the interface which characters from each line to assign to which variable. We'll first select the message that we wish to assign variables for. We'll start with our header line. You'll notice that the data file has now changed to just show our header lines. Let's click the plus sign to start assigning data for our header line. We can choose how the information in the file is separated. Your data file might be separated with characters like commas or semicolons, or you might have fixed with columns. You can also assign data manually. In our data file, we have fixed with columns, so I'm going to choose fixed with and then click Next. Here we see our data line, and we will show the interface where the separations are between our different sets of information. Our first piece of information is timestamp, so we need to separate this out from all the other characters in the line. We'll do this by just clicking to produce a separation. We've put a separation at the beginning of our timestamp, and now we'll put one at the end. If you've accidentally placed a separation in the wrong place, you can move it by holding your mouse over the separation, clicking, and dragging. The other piece of information from this data line, if you recall, is the reactor. Let's separate out the reactor. Now that we've created our separations, we can click Next to assign variables. We'll assign our timestamp variable to the timestamp that we've defined by clicking on timestamp, holding, and dragging to the Add Variable box. Just like that, we've assigned our variable timestamp to the actual timestamp data from our data file. And we can do the same with tag prefix. Now let's click Finished since we've assigned our variables for this data line. We'll now move on to our data message type. Let's click the plus sign to start assigning data. Again, we have fixed with columns here, so we'll choose fixed with, and then click Next. Here we can create our separations. If you'll notice, in the data file, our value starts at the tens place. We'll need to create a separation starting at the tens place. So let's use our cursor to click and create that separation. Now let's define the end of our value. If you recall, the other piece of information that we need from this data line is the element. So let's separate out our element. Now we've defined our separations, so we can click Next and move on to assigning our variables. We'll assign our value variable to our value, and our element value to our element. Now let's click Finish. I'll click the green plus to add a new action. My action will be to store our data in PI. Now, we don't yet have a tag name to specify, but I'm just going to pretend for the time being that our tag prefix is our tag name, and we'll go back and edit this action later. We'll click and drag our tag prefix variable to the tag. You'll notice that all of the required parameters for the store in PI action are denoted with a star. Let's assign our timestamp variable to the time parameter and our value variable to our value parameter. We can click Validate to make sure that this syntax is proper. When we get a green check mark, we know that the parsing was successful, and we can click Add. Now let's click Close. Now, as I said, we don't want just our tag prefix as our action. So let's edit this action. We'll enter in some additional text to tell the interface to combine the tag prefix with our element. To do this, we'll use the AND character to concatenate these two pieces of information. I'm going to concatenate them with an underscore between them. We'll validate our result again, and then click Apply. We've now configured our interface to read in the timestamp and reactor from our first line, read in our values and element from the C lines, and then send all this information to Pi with a new tag that the interface will create for us. Now that we're finished configuring, we can click Save. And then we can close UFLDesigner. This completes our advanced configuration.